So now we can see one of the experiment of Power System Lab 2 for ME Power System Engineering students semester 2. So this is experiment number 7, simulation of solar PV energy conversion system. So the aim of this experiment is to simulate a solar PV system to run a DC load controlled by a suitable controller. So we all know there is a solar PV system with it will have a solar PV cell and a battery and then a load. The load may be if it is a DC load, you can directly connect with the help of a charge controller circuit. If it is a AC load, you need to again invert it and then you need to run a AC load. That is up to you, depend upon your application. So here I have used a DC load. So I can directly connect the solar output to this DC load with the help of a charge controller. The charge controller may be with the help of chopper circuit. It may be a buck converter or boost converter or buck boost. And maybe depend upon your load, you can choose the type of controllers. This is what you can do. This is the objective of this experiment. In software, you need is MATLAB 2014 or updated version of this system. The theory behind this is, so there is a photovoltaic model. The model is given in this figure. This is a diagram of solar PV cell. So we all know the behind this PV cell, what are the parameters and what are the equations like that. Everything we already, this derivation is there. You can refer. So here the parameters, T represents the actual temperature, Tn represents the nominal temperature, Ki represents the coefficient, G represents the irradiation of the device surface, then Gn represents the normal irradiation, like that. There are some parameters, and this is a solar PV module parameter. So maximum power is 85.14. Parallel, that is parallel string. There are two parallel strings. Series, per each string there are one series connected module. Then cell per there are 36 number of cells. Then open circuit voltage is 22.2 volt. Short circuit current is 5.45 amps. Then voltage at maximum power point VMP, that is 17.2. Current at MPP is 4.95 amps. Temperature coefficient at open circuit voltage, that is minus 0.645. Temperature coefficient, that is at short circuit current ISC, that is 0.14. Then sun irradiance, that is B, in web, that is watt per meter square. And then another temperature, that is in temperature, another input. So these are the inputs to the solar cell, the irradiance and the temperature. Temperature, that is in degrees Celsius. So here I have for this conversion, for this load in between the solar panel and then this load, I have used a converter. Here I have used a DC to DC chuck converter. So chuck converter is it's a buck boost converter. So it has both. It can able to it can be used as step up or step down, depend upon your application. You can use. So here we have used the MPPT controller, and the MPPT algorithm has been used, trial and error method, hill climbing method, whatever method you can use, and then you can do the MPPT method, and the maximum power can be tracked for that solar cell. Then it is controlled, the output of the solar cell is controlled by this charge controller, this is the DC to DC chuck converter. Then with that, this is circuit diagram of the chuck converter. So these are the, you need to design the values of capacitor. Then diode, you can use IN4001 diode, and inductor, that is L2, C2, L1, everything the load everything we need to design. And then at last I have drawn the simulation diagram for this. So this is simulation diagram, a solar panel. And then for MPPT, I have used one algorithm that and that is defined here. Then there is here the chuck converter is designed here. I have used a MOSFET based chuck converter, then that is given, and then output, low output, you can able to find the output, and these are the output waveforms of a solar PV system. So this is what it has been done. So here the solar array is formed when several identical modules contain series, and output voltage is increased proportionally to n SCR, and the current remain unchanged. Okay, so this is what the solar array. So here for this Simulation diagram, I have used a model that is available in the MATLAB. Okay, so the two inputs I told, right? What are the two inputs of that PV cell? These are the two inputs, the last two rows, irradiance and then temperature. So that is what we have given as the input. So by changing the irradiance and then by changing the temperature, the output values also you can analyze various output values. You can able to get it. You can fetch various values of output. Then that output values you can analyze and then you can plot separately. That also you can extend this work also. So this is the output waveforms we are getting. For that, this is the output waveform that is across the DC load. Okay. So thus the simulation of PV solar system is executed using MATLAB, and this experiment has been completed. Thank you.